Hi everyone, in this video we are going to discuss about Traffic Manager. Traffic Manager topic has two parts. In first part we will discuss about what is Traffic Manager, what are the routing methods and how exactly it works. In second part we will see the deployment of the Traffic Manager. If you want to go through the complete course, you can purchase these courses from my website, that is techlearning.spy.com. All the information is given in the description. If you want to check out the course content, just click on course and click on preview. So left hand side you can see all of the course contents. Other than individual courses, course packages are also available where you can find out the decent discount on these courses. Let's get back to our topic. So in Traffic Manager, we are going to discuss about what is Traffic Manager and how it works. So when we talk about the Traffic Manager is also like a load balancer here. So we call it as a DNS based load balancer. Now, what is the meaning of this DNS based load balancer? First of all, we need to understand how exactly this load balancer or traffic manager work here. Okay, so I'm going to draw a diagram. So that is going to help you to understand the concept. So let's say this is your traffic manager here. So this traffic manager will be connected via the DNS. So this is your DNS. Okay, and then finally, let's say this is your client, or you can say that this is my laptop. Okay, so this is a client. So now what happens? Because this is a DNS based load balancer, we create an entry of this traffic manager inside this DNS. So first of all, we have to create a zone here. Inside that zone, we will make an entry. So let me take the same example here. That is, let's say I'm trying to access www.learninghubtech.com. So it will reach out to the DNS. In DNS, we will create a zone here, and the name of zone will be learninghubtech.com. Inside this zone, we will create one record, and in that record, we will mention www.learninghubtech.com, and then there will be a DNS name for this traffic manager. Correct. So there will be a mapping with the DNS name of traffic manager. So this will be the record, and this will be a CNAME record. Okay, so first you will type learninghubtech.com. It will reach to your DNS. It will be resolved with the help of this DNS. Learninghubtech.com will be resolved to this DNS name of traffic manager. So my DNS will get to know about the traffic manager by this DNS name. Now traffic will reach to my traffic manager. Okay, so finally what we do here, we add the endpoint. So let's say this is two endpoint here. One endpoint name is VM1 and the second endpoint name is VM2. In the previous session in load balancer and application gateway, we were calling it as a target, but here the technical term is the endpoint. So these endpoints will be added to the traffic manager here. Okay. Now how this whole cycle work here? Let's say you are typing learninghubtech.com on your laptop. So it will reach to the DNS. Inside the DNS, one record has been created. And against that record, learninghubtech.com, against that record, a DNS name of traffic manager is mentioned. So it will reach to the traffic manager. Now traffic manager is going to select one appropriate endpoint, okay, from the list of the endpoint which are attached to your traffic manager here. So traffic manager, let's say, selected VM1. Okay, so IP address of VM1 will be returned back to this DNS, and finally this DNS is going to return it to my client. As soon as this client got the IP address of your VM1, it will make a direct connection with the VM1 here. Fine. So this is how the basic functioning of traffic manager works. So before that, before getting into the depth of traffic manager, one thing I want to highlight here about the traffic manager. So let's say this is your traffic manager. In the previous diagram, I had taken the example of the virtual machine that you can attach to virtual machine as an endpoint. That is quite possible. You can do that. But instead of your virtual machine, you can attach anything here. So right now you have knowledge of load balancer, you have knowledge of application gateway, you have knowledge of virtual machine scale set, and also you know how things happen in the on premises. So it is up to you what you want to attach as an endpoint here. Let's say you want to attach an application gateway here. So you attach one application gateway, okay? So application gateway will have a IP address, public IP address. You can add that public IP address with this traffic manager. Behind this application gateway, let's say you have 50 virtual machine. There are 50 virtual machines here, so on. So they will be attached to your application gateway, right? Similarly, if you want, you can attach your load balancer also. And behind load balancer, let's say you want to attach your virtual machine scale set. So you know that how to create this virtual machine scale set, and then further how to attach it to the load balancer. Now this load balancer will have the IP address. Okay, that IP address also you can attach as a endpoint. Correct? Instead of that, suppose you want to, there is some infrastructure in your on premises. Let's say this is your on premises web server, and if you want to attach this web server, so there should be one IP address on it. Okay, so that IP address you can attach with your traffic manager. Not only this one on premises, suppose you have some infrastructure on AWS. Correct. In AWS, you have created the load balancer or a simple virtual machine where you have hosted your website. Anything can be there in different cloud computing infrastructure. It can be AWS, it can be Google Cloud. So you will have one IP address, so you can just come and attach it. So with traffic manager, it is not necessary that you can only attach the virtual machine. You can attach a wide range of endpoint here. Okay, so now you have the skills. Now it is up to you how you design your overall infrastructure. So once we get more information about the traffic manager, you will get to know that what are the benefits of attaching multiple component with the traffic manager here, right? But to understand or to simplify this overall process, what I have taken two virtual machine, VM1 and VM2, so that you will understand actually how this traffic manager works. This part you have already understood, how to apply this application gateway, okay, and how to set up load balancer, virtual machine scale set on premises. This you know in piece and piece kind of thing. Pieces you have the knowledge. Okay, now we are going to integrate it with the traffic manager. So just to simplify this overall process, we are going to do whole lab with two virtual machine, VM1 and the VM2 here, so that you can understand exactly what is the actual work of this traffic manager and how exactly it works. Right now I have just given you a simple scenario of the traffic manager. Now come back to the traffic manager here, focus here. So I told you that, let's say same example, let me repeat once again, learninghubtech.com. It reached to the DNS. From DNS is find out the name of the DNS of your traffic manager. Then finally session reach out to the traffic manager here. Now I said traffic manager is going to select one appropriate endpoint. Okay. Now, how this traffic manager is going to select that appropriate endpoint? What is the process? What is the mechanism? That mechanism is known as routing method. And this routing method makes this traffic manager special. This is the characteristic of the traffic manager, routing method. So there are six type of routing methods are available. Okay, one by one, we are going to discuss each and every routing method here. Let's say I'm just giving you a simple example of the routing method which is known as the priority routing method. So while configuring this traffic manager, suppose you selected priority routing method. So based on this priority routing method, your traffic manager is going to select the appropriate endpoint. So what will happen in this case? Whenever you will try to attach any endpoint with your traffic manager, it will assign some priority to it. Let's say this is my endpoint and this endpoint has priority 1 and the second endpoint has the priority 2, right? So now this traffic manager will have a priority table inside it, and in that priority table what and all information would be there? The name of the endpoint, okay, the IP address of the endpoint, and the priority which is assigned to the endpoint here. Now when this traffic reach out to the traffic manager, now traffic manager will think which endpoint I should select. If you have configured routing method as a priority routing, it will see that who has the least priority. So in this case, in this scenario, VM1 has the least priority here, that is priority 1. So the IP address of VM1 is going to be selected by the traffic manager, and this IP address will be returned back to your DNS. DNS is going to return it back to the client, and then finally client will make a direct connection with this VM1 here. So every time when you hit this website, it will go and connect with VM1 only because the VM1 has the priority 1. Let's say because of some reason VM1 is down. In that case only, it will search out who is the next priority. So there are only two endpoints in this example. So priority 1 is down. So who is the next priority? Priority 2. So only in that condition, your session is going to connect with the priority 2. Okay. Now, how is this useful? In which scenario we can utilize this priority routing? Suppose you want to configure the failover in your environment. Instead of VM1, you have connected a application gateway, and behind that application gateway, there are hundred of virtual machine. Okay, that is your primary site. So every time you want that, whenever user session comes, it should go to your primary site. That is your primary site, and you have set the priority 1 on that, lesser priority. Okay, so every time whenever session come, it will go and hit to the this application gateway, and behind that there are hundred of virtual machine. But suppose your primary site is down, then what do you want to do? So always what we do, we keep one backup site also. We call it as a failover site as well. So whenever your primary site is down because of any reason, so if you have set priority routing method will see that who is the next priority available. So let's say this is a next priority, and here you have set a load balancer. Behind load balancer, you have set a virtual machine scale set. As soon as this one will be down, your traffic manager will start routing your whole traffic to this failover site. Okay. If there is a virtual machine scale set, automatically virtual machine will start deploying in that environment. This is the real-time case scenario of the priority routing method. Just focus on this diagram and let's understand how this traffic manager works. So this is client and this is my DNS and this is the traffic manager here. Okay. And with traffic manager, these are the endpoints which are attached. And this endpoint can be anything. It can be your virtual machine, it can be application gateway, it can be virtual machine scale set, anything. Okay. That is up to you how you design your environment. Whenever this user, okay, typing anything, let's say any website or application deployed on these endpoint and is trying to access them, so first a DNS query is going to reach out to the DNS service. Okay, now DNS will forward it to the traffic manager. This is your step 2. Now based on the routing method what you have configured on your traffic manager, traffic manager is going to select one appropriate endpoint. Let's say this traffic manager selected this endpoint. So the IP address of this endpoint will be returned by this traffic manager to the DNS. Okay, you can see this is step third. So the IP address is returning back to the DNS. Now DNS will forward it to your client, and then client will have the IP address and it will make a direct connection with the endpoint here. Okay, this is how the basic functioning of the Azure Traffic Manager, and same thing is written here. If you go to the priority routing method, let me maximize this one. In case of priority routing method, on this traffic manager, I have selected routing method as a priority routing. Okay, so you can see there are three endpoint has been attached with this traffic manager, and this traffic manager is going to maintain one table, and in that table the name of the endpoint, so you can see this, the name of this endpoint is the primary, this is failover A, this is your failover B here. So name has been mentioned, against that their priority has been mentioned, and their status. Okay, let's say this person is trying to connect. First it will reach out to the DNS. DNS is going to forward it to the traffic manager. Now traffic manager will check this table. As per this table, this primary has the least priority. Okay, so this one will be selected, but unfortunately you can see primary one is down because of some reason. If primary one is down, okay, primary is down where the priority is one. If it is down, the traffic manager again will check out the table. In this table, the next priority is priority two, and it is assigned to the failover A. So traffic manager is going to select the IP address of this failover A, and it will return it back to the DNS, and DNS is going to return it to the client, and then client will finally make a direct connection with your failover A site that has the priority 2. Fine. So very simple. Logic is very clear here. The second routing method is the performance routing method. Performance routing means if any user is trying to access the application which you have hosted, okay, it will see that with which endpoint it has the minimum latency. Okay, suppose this user is sitting in some country, okay, and you can see your endpoints are connected in West US, North Europe, and the East Asia. So in traffic manager, I have selected the routing method as a performance routing. So in this case, it will create one table, and in this table, it is going to mention that, let's say this user is, if this user try to access West US endpoint, what will be the latency? So latency is 15 millisecond. If this user is trying to access the application from endpoint 2, so what will be the latency? That is 75 millisecond. If this user is trying to access your application from endpoint 3, which is East Asia, so latency is 150 millisecond. So what will happen? So user is sending a DNS query, and then it will reach out to the traffic manager. On traffic manager, you have configured performance routing. So traffic manager is going to calculate the latency now. Latency based on your source and this destination. So these are the different timings. Okay, now traffic manager will see that, okay, with West US the latency is minimum, so this user will get the highest performance with the West US here. So traffic manager is supposed to select your this endpoint, right? Endpoint one. But if this endpoint is down, in that case, it will go and see that who is the best performing endpoint for this user. Who is the next one? So next one is the endpoint two here. So he will go and select this endpoint, return its name to the DNS. DNS will return it to the client, and then finally this client will make a direct connection with this endpoint here. So only thing which you have to remember in this case, in case of performance routing, traffic manager calculate the latency between you and the target here. Okay, so how much time it is going to take. So whoever will be the best, it will return back the best endpoint detail to the DNS, and DNS is going to forward it to the client here. Fine. So this is my second. This is known as the performance routing. The third one is called the geographic routing. So suppose if my user is based in India, and in India region also I have some endpoint. So I want that whenever any user from India region try to access my application should connect to the India region based endpoint only. So that you can do by the geographic routing. So let's understand it by this diagram here. So in this diagram, you can see there are endpoint here. This is endpoint one, which is based in Germany. Then I have created a nested profile, which is configured for your Mexico and the Asia region here. Now, one thing you need to highlight here. So inside Traffic Manager, basically the actual name is Traffic Manager Profile. Inside this Traffic Manager profile, if I want, I can put a nested profile also. Okay, inside one traffic manager, I have put the second traffic manager here. This traffic manager will be known as nested profile. Okay, so right now this is attached as an endpoint here. Fine. The second is the endpoint 2, and here if somebody is trying to access your application from location other than Germany, Mexico, and Asia, should be connected to this endpoint 2. Then further, what we have done in the nested profile, we have attached two endpoint A and endpoint B. And in this nested profile, we have configured the priority routing method. So A has priority 1, endpoint B has the priority 2. Okay. This traffic manager has the geographic routing. This traffic manager has your priority routing configured on it. Let's see how it works now. Suppose this user is from the Germany region only. So if it is from the Germany, request will reach out to the DNS. DNS will forward it to the traffic manager. Now traffic manager will see the source of this user. This user is from the Germany. So we have an endpoint already configured in the Germany region. Okay. So, and in traffic manager, we have already configured my geographic routing. So my traffic manager will understand, and it is going to select this endpoint here, which is based in Germany, and it will return back the detail of this endpoint to DNS. DNS is going to forward it to the client, and then this client will make a direct connection here. Okay, but suppose this user is from the Mexico. So what will happen in this case? Request will come to your DNS. DNS will forward it to the traffic manager. Now inside traffic manager, you can see there is a other traffic manager. There is a nested profile, and that is configured in the Mexico. My user is in Mexico. So what this traffic manager is going to do, it will give this request to this traffic manager because this is based in Mexico. Now with this traffic manager, there are endpoint, and endpoint A has priority 1, endpoint B has the priority 2, and on this nested profile, priority routing method has been configured. So based on that priority routing method, this nested profile is going to select endpoint A because this endpoint A has the priority 1. Correct? So this IP address is going to return back to this traffic manager finally. This traffic manager will give it to the DNS, DNS will give it to the client, and client is going to make a direct connection with this endpoint A here because it has the priority 1. And this user is from the Mexico. Okay, so that is the region. It is going via this Mexico nested profile, and finally it will reach here. So this is how your geographic routing work here. The fourth one is the weighted routing. Now, what is weighted routing? To understand this one, just come back to my diagram here. So what you are going to do, let's say instead of this routing, remove this. You have selected weighted routing here. So when we select weighted routing, it will ask me to give some weightage to the endpoint. So because this is priority, so we had given the priority earlier. So remove this one, remove this also. Fine. So instead of priority, it will ask you to give the weightage. So let's say I'm giving 75 weightage to this one and 25 weightage to this one. So what will happen in this case? Let's say four user sessions are coming. Out of four user session, three will be connected to this one, VM1. For three session, your traffic manager is going to select VM1 as an endpoint and return back its IP address to the client. And for one session out of four, okay, traffic manager is going to select this endpoint and return the IP address to the client, and then client will make a direct connection here. So out of total four, three will be connected to VM1. Why? Because it has 75 weightage, and one will connect to VM2 because it has 25 weightage here. Now, what is the real-time case scenario of this one? So let's understand it with the help of example, how exactly and in which scenario we use this weightage. Suppose this is your traffic manager now, okay? And in your company, your application is deployed on your on-premises setup. So this is your on-premises. Now your company has decided that you want to move to the cloud environment, and this setup you want to migrate to your cloud environment here. But this is currently on production, and you cannot take any downtime also because this application is accessible 24 bar 7. And if you go for any downtime, okay, so there might be a problem for your company, and it may be a financial impact. This is one fact. Second fact is that when you decided that you are going to migrate your on-premises setup inside your cloud environment, okay, you are still worried that whether it will work properly or not. So you do not want to take the risk. In that case, this weighted routing method comes into the picture. So what we are going to do, so already in on-premises we have the setup. So same replica of the setup we are going to create here inside the Azure infrastructure. And then we will, let's say this is Azure. And then we are going to add both of them as an endpoint here. This is my endpoint one, this is my endpoint two. On my traffic manager, this is my traffic manager now. So according to my requirement on my traffic manager, I have selected the weighted routing method. Now, how this weighted routing method is going to help me, that we need to understand. As of now, when all of this traffic comes, okay, from outside, everything is going to be diverted to your on-premises, and 100% user sessions are connecting on your on-premises environment. Now, if you want to do migration, first you will deploy your infrastructure in the Azure. Okay, you will do your initial testing. When you are 100% sure, okay, it is working fine. So what you will do, you will connect this Azure as an endpoint to your traffic manager. Now, instead of diverting complete traffic because you do not want to take the risk, so what you will do, you will test the environment and you will see that any issues are reported by users or not. Is there any bug or not? Okay, so you will reduce this traffic to 90%, and here the weightage you will make as a 10%. The weightage on on-prem will be 90, the weightage on Azure will be 10%. So what will happen if 100 sessions are coming? 90 will be connected to your on-prem, which is already working fine. 10 will be diverted to your Azure infrastructure. Now you will study this, whether any issue while accessing your application, any issue or escalation reported by your customer or not, is there any bug? If everything is fine, if it is working as expected, what you can do, you can reduce this weightage to 70% and you can increase it to 30%. So overall 30% traffic is going to the Azure environment now and 70 is here. If it is working fine, you are confident that okay, your Azure infrastructure is doing good. What you can do, you can do 50-50, 50 here, 50 here. Okay. Now, if everything is as expected, Azure is working, there is no user issues reported. what you can do, you can make it as a 0 and you can make it as a 100. So all of your user sessions now is going to be directed on your Azure infrastructure. But you will not decommission this on-premises environment immediately. You will study this for a few weeks. If everything is fine here, then finally you can decommission this environment. You can remove your server and decommission this on-premises environment, and all of your user session will be successfully migrated to your Azure infrastructure. And this is a very important routing method. Very often we use this weighted routing when we do the real-time scenario setup, especially this migration thing here. The fifth one is known as multi-value, and sixth one is the subnet here. In case of multi-value, what happens? Let's say this is your client. This client will reach out to your DNS. DNS will go to your traffic manager. Here you have configured your multi-value. So in case of multi-value, instead of selecting one IP address, it will take the detail of both of the endpoint here. Okay, and then it will return back it to the DNS, and DNS will return it to the client. Now this client has detail of all the available endpoint. In this case, these are two endpoints, so it will have the details of two endpoints here. So out of two, it will connect to one endpoint. Okay, but suppose there is a problem in connecting with one endpoint. So automatically, because it has the detail of the second endpoint as well, so it is not going to make another query here. Instead of that, it will start connecting with the second endpoint. Okay, because both of the endpoint knowledge or information already is there with this particular client here. So this is how this multi-value work. Finally is the subnet. Suppose if you want to decide that a user should be connected via a specific subnet, so you can mention that subnet. Let's say you want 10.0.0.0/16. Okay, from this network, if anybody comes, they should be only connected to this VM1. If someone comes from other subnet, they should be only connect to this VM2. So like that, if you want to configure, you can configure with this subnet and routing method. So in short, in general, routing method is very important in traffic manager, and based on your routing method, this endpoint is going to be selected here. Okay, so total 6 type of routing method we have. What we discussed: one is my priority, second is my performance, third is the geographic, and the fourth is the weighted, fifth one is the multi-value, and sixth one is the subnet here. Okay, so this is how this traffic manager works.